If you're thinking of installing solar panels on your RV, you're going to want to stay tuned to this video, because I'm going to show you step by step how I install these 4 100-watt solar panels along with the solar charge controller, cutoff switch, breaker, and all the accessories on my 2021 leisure travel van twin bed. Now, even if you don't have a leisure travel van, I think what you'll see in this video can help you in the installation on your particular RV. And as always, I'll put links to all of the components that I use down below the video. And if you want to help support this channel, please use those affiliate links. And if you find this video helpful, please don't forget to like it and subscribe to my channel so you can see more helpful videos like this. Before we get started, if you're not completely comfortable doing your own installation, I suggest you seek the advice of someone experienced in this area so that you don't cause damage to any of your equipment or even hurt yourself. Because this is a rather detailed step-by-step video, it is long. So if you are only interested in certain parts of the installation process, you can use this guide to skip ahead or backwards to the parts of the video that you're most interested in. Now, for my installation, I chose the Renogy 100-watt monocrystalline panels. There are very good panels from any number of vendors out there. Bouge RV, Rich Solar, New Power, HQST. I looked at all of those. There's slight differences in dimensions. I ended up picking the Renogy because of the higher voltage. They operate at 20.4 volts, whereas the others are anywhere between 16.7 and 18 volts. It doesn't make a huge difference, but that was my choice, and I think any of these will work well for you. And they generally run around $100, sometimes as low as $80 per panel. In addition, I bought the Victron SmartSolar MPPT charge controller with 100 volt 50 amps capability. And as you'll see during the installation, I have a cutoff switch before the solar charge controller and a breaker after it, and I'll discuss the other hardware as we go through the video. Now, I've laid out the panels. I haven't attached the brackets to the roof yet, but I've laid out the panels so I can see how everything fits. So you see 2 of the 100-watt panels will fit up towards the front, and then I can put 2 more panels on the back driver's side. And in fact, I have room, plenty of room, to put a 5th panel right in here. However, an odd number of panels is a problem if you're using a single charge controller, because then the way the voltages and the currents will combine, you really won't get the advantage of the 5th panel unless you put it on a separate charge controller, and that's not what I intend to do. And if I removed or moved my dish antenna, I could put a 6th one across perpendicular to the other panels. So I could put a 5th here and then a 6th there. But that's an opportunity for future expansion from 400 watts to 600 watts. Now, I also considered putting 2 200-watt panels on here instead of 4 100-watt panels to get to 400 watts total power. It would be a lot more convenient just to have 2 panels. However, the widths of the most narrow 200-watt panels that I could find would start to encroach and actually go over this curved part of the edge of the roof. And I didn't want that. That would be a problem with both mounting them. So I decided to stick with these 100-watt panels. So before I can install the panels on the roof, I have to install the mounting brackets. So with this Renogy panel, I bought the Renogy Z-mount brackets that come with the hardware to mount it first to the panel itself. And so there are different holes along here, so you have options to mount on different places. Whatever works for you, I'm going to mount it here. And you use these bolt washer on one side, washer lock washer and bolt on the other side. And I'm going to put a little bit of this blue Loctite on the threads just to help hold so they don't vibrate loose. This is a removable Loctite thread locker, but it helps hold things in place. So I have to put all 4 of these on, each 4 corner. And let me just do that. Finish this one panel here. And you want to make sure that when you tighten everything down, it's snug, and then the bracket is flush against the side of the panel. Now these Z-brackets come with mounting screws that are intended to be screwed into the roof of the RV. We're not going to do that. The way the roof on the leisure travel van is designed, there's not a whole lot to hold on to. So we're going to use this 3M VHB tape, which apparently everybody uses, and they say once you stick this to the surface, you're not going to get it off. And lots of people just put the tape right on this bracket here and then attach it to the roof that way. And apparently that works well for them. I want a little more surface area contact between the panel and the roof, and what some people suggest is getting a aluminum plate. So here's a 1/4 inch aluminum plate, which is 3 by 4. So it a little bit more than doubles the contact area. And we're going to attach it with these screws, flathead screws, this way, and then we'll put a washer. I have one too many washers. A washer, flat washer, lock washer, and a nut on the other side. So when this is down on the surface, all of these will be on the upside. So I had to prepare this plate. So I had to drill these holes, clearance holes for the screw, and then I had a countersink so that the screw head is below the surface so it doesn't interfere with the tape, because we're going to put the VHB tape on this surface here, and we have double the contact surface. And we have to put the screws in first and then put the VHB tape on top of that. And then we get all 4 corners set up. We can then mount this to the roof. I got these plates from a metal supply place, and I'll put a link to that company down below the video. I had to take the burrs off the edges because they punched these out. And I used a small tabletop drill press to drill the holes, and that wasn't working so well for the countersink. So the countersink, I had to use a hand drill to countersink. And one of the concerns is that these screws might just rotate when I'm trying to tighten on this side. So a trick I learned from Sandra online, from the Unity forum, is I used my Dremel tool to put a slot in the tip of the screw. That way, when I'm viewing it from the top side and putting all the hardware on top, if it starts to rotate, I can put a screw in there and hold it tight. And the same for when I want to take the panel off. Maybe I want to clean underneath, be able to do that. So I'll put these on here, and this is only finger tight for now because I want to be able to put the VHB tape on here before I bring these up on the roof. And this is double-sided tape, so I'll put one side, stick it to here, and then when I'm on the roof I can take the other side off, and I can move these around, loosen this as necessary. Now, what I did with these, besides taking all the burrs off, is I used some steel wool on the surface and soap and water, and then alcohol on this surface here that is going to be mounting to the VHB tape. And I must admit that my alignment of the screw holes is not perfect, so I'm going to use this circular file, try and make everything fit. So anyway, I don't have a machine shop, so I do the best I can. So to apply this 3M tape, you just peel it back, set it on there, And then I'm going to trim it with this blade. And then you want to apply pressure. So I have this roller. Apply pressure to the edges too. So as you see, I have 2-inch wide tape. I couldn't find 3-inch wide tape. Or I could go this way with 2 strips, or I go this way. So now that's on there. And then this panel will be ready to be mounted on the roof. So before mounting the panels on the surface of the roof, I needed to clean it thoroughly. Now my RV is only 18 months old, so it isn't too bad. The surface of the roof is pretty clean, but nonetheless, I had to clean with soap and water and rinse liberally with fresh water, and then wipe down the surface with 70% isopropyl alcohol and paper towels so that I get a good bond with the 3M tape. So 3 considerations go into placing the panels on the roof. So we talked about the first is, where do I have open space enough to fit them? And so I have these other 2 panels back here on this side where there's lots of space. And then I fit the one in front of the air conditioner, and the other one is up front on the outside there. Second is to make sure I don't interfere with any of the other stuff on the roof, notably the die-core sealants around the edges of things like the skylights and the fans and so forth. And I don't have much of a problem here. Over here I have lots of room. Over there I had to pay a little bit of attention and adjust the position, because you don't want the feet to be right up against the die core, and you also, like that one that's in the middle there, I don't want it to be too close and interfere with the opening and closing of the skylight. And then I also want to make sure I'm far enough away from this lip, so as the roof comes over and curves down, there's a little lip that goes up, and if I have this plate too close to that, there will actually be a slight void there, so I want to keep that away. Then the last thing is the orientation of the cables that come out of the panels. So I have this one facing with the cables to the back and this one facing the cables to the front, even though I'm going to bring all the cables in the end to the front of the RV to go down inside and connect up with the pre-wire. So why did I do that? Well, I'm going to put these 2 panels in parallel. So as you see here, I have the plus and minus connected, and so that would be much easier to do than having this panel flipped around the other way. Then I'd have to have an extension cable coming back. So now I can simply connect those 2, and then I have the plus and minus, and I just make cables of equal length to go from here up to my junction box, which will be in the right front corner of the roof. So you can do it either way, but this is just the way I preferred to do it. Here's another view from the skylight. I'm standing up on a ladder in the skylight, and again, I want to make sure that things don't interfere with one another. Everything is clear here, and everything here is clear. One other nice thing about having this extra aluminum plate, not only does it double the contact area, but if I want to take the panel off, I just take these screws off and the whole panel will come off and the bonding plate will still remain. And so now that I have these things positioned and I have the surface cleaned, I'm ready to do the install. Now I think there's several different ways of bonding these down to the surface. So one way, if I weren't on top of the roof and this weren't so awkward, is I would take the tape off of all 4 pads and then just gently set this in place. But I don't think I can do that very well here, and if one of the pads gets stuck down before I have it aligned, I'm out of luck. The second way, which I think a lot of people do, is to mark these plates with a pencil or something, and that way they can take the panel off of the plates and then put the plates on and then mount the panel on top. There's not a lot of play in those holes. I could make them wider, but I chose not to. So I don't like that method either. So what I'm going to do is I'm going to take the nuts and lock washers off the bolts so that the panels are free to come off of the aluminum plates. And then I'm going to lock down one in the position that I want, maybe in that back corner. And then I'll lock down the other one in front of it. And then I'll go around either end. That way I can lift this freely to a certain degree, but I already have a locked in position. So we'll see how well that works. Now the specs on the 3M VHB tape say it'll take 72 hours to fully cure at room temperature. So to take into account the cool nights, and I had plenty of time, so I waited a week for it to cool before I put sealant around the edge. So it's important to put some sort of sealant to keep the water from getting to the VHB tape. And probably the most common sealant used on these roofs is Dicor. But someone suggested to me to use 3M 5200 marine adhesive and sealant. And unfortunately, they won't ship that to California. Nobody will ship it to California. So I had to settle on the 4200 adhesive sealant. And the reason why I wanted either the 5200 or the 4200 is, in addition to being a sealant, it also is an additional adhesive. So I put bead all the way around the edge here to keep the water from intruding on the VHB tape and to add a modest amount of additional adhesion to the plate. And now I'm ready to put the panel back on, bolt it down, and I'll use some of that blue Loctite on the bolts here as well so they don't vibrate loose while I'm driving down the road. And the 3M adhesive sealant takes 24 hours to fully cure. Since I did not order the solar installation from Leisure Travel Vans and I'm doing it myself, I have to figure out how to bring the solar cables from the roof down into the house and connect it to the pre-wires that Leisure Travel Van installs, even if you don't get the solar panels. So let's take a look at the pre-wire and where they put it. So if you take out the screws holding in this control panel, which is above the entry door, you will find, besides all the other cables that support the controls that you see in that panel up there, you'll find the ends of the pre-wires for the solar installation. All right, so I've opened up that compartment, and down in the back are the solar pre-wires. So there's a 8-gauge red wire, 8-gauge white wire. Those connect to your solar panels. And then there's a smaller gauge white wire, which I believe they use to ground the case of the solar charge controller. So you see that's buried back in here, and it's actually down below. So where does it go? Well, it goes behind everything here, behind this cabinet. You can't see it there. And it goes into this compartment here, which is hidden. So if you take these screws out, let me take this out, you will find those cables here. You'll find a big, nice big loop of the cables. And that loop, part of it goes over here to the ends of the cables, and then the rest of it is fished down behind this wall, inside, down below, and then across into the battery compartment. So how do I connect to that? Well, unfortunately, there's not enough room here to drill up into the roof. And besides, this is pretty close to the edge of the roof, and I wouldn't want to drill there. Might not get a good seal on a gland. So there are other places and other options to consider. Now, I think one very common approach, and I think Leisure does this themselves, is to drill a hole from this compartment, the ceiling in this compartment, up to the roof. And I think you want to be pretty far away from the edge here, maybe closer to the front part of this, and you can measure this across and kind of estimate where on the roof it will come out. And I believe where this corner is angled, I believe this is the seam that you can see on the outside, which is the transition between the front cab and the back house. So you want to stay back from here, so somewhere up in this region in the front. And it would be best to drill a small pilot hole up first to get a good idea of where you're coming out on the roof, to make sure that you're far enough away from the edge of the roof and the joint between the cab and the roof and the house, and you have enough room for your gland or connection box to seal it up there. Anyway, this is probably the most common way to get to the roof. Now, how do you then get to these wires? Well, you could drill through here. You have to be careful because this is not completely connected on this side, so you'd have to drill through the back edge and into this compartment. But I think there's an easier way, and that is you drill through the wood panel back here, and if you look on this side, you see you only have a thin layer. This is cut out, so you're only drilling through this piece of wood, and you could actually unbundle this cable and fish the end of this over into this compartment and connect to your solar panel wires coming down from above. Now, if I was simply bringing two solar cables down from the roof to connect to the pre-wire, that's exactly what I would do. I would drill a hole in this compartment, and then I would drill through there and connect to the ends of the cable here. No need to actually go into this compartment to these wires. That wouldn't be terribly helpful. I mean, it will shorten the length of the wire by a few feet. That's not going to make a big difference in terms of power loss. But in my case, I also want to bring a Starlink cable down, and there's no AC outlet on this side of the RV. The AC outlet is on the other side that is convenient. So if I brought the Starlink cable down and the solar cables down through here, then I'd have the Starlink unit sitting over here, the router, and then it needs AC power, and I have to string a AC power cord all the way over to this side, and that is not very clean as far as I'm concerned. So what I think I will do, what I'm planning to do, is take another approach to drill partway through the roof and then down into this compartment, and then I can bring the solar cables in, cut these pre-wire, connect my solar cables behind this panel here, out of sight and out of mind, and then I can route the Starlink cable through this compartment, and there's an open space behind all of this. Here's the center cabinet, and back behind this wall is an open space. And you can see from this image what it looks like back in there, and then I can bring the Starlink cable back around this side and bring it through the panel back here. In fact, I could drill a little hole and fish the Starlink cable through that, and then my Starlink system could sit in this compartment, and then the AC wire simply goes down here, and it's not so obtrusive. There is a way to bring the solar wires down from the roof into the compartment where the solar pre-wires are located without having to drill any additional holes in your roof, and that is to use the location and the holes where the Sirius satellite antenna goes into the roof here. And so what you would have to do is remove all that sealant and then use the same holes that the radio antenna goes through the roof, and I'll show you where that comes out behind the center cabinet between the cab and the house. Now the thing is, you would have to figure out how to raise that antenna up at least the thickness of the solar panel wires so that they can so that they don't get crushed by that plate that holds down the satellite antenna, and then you have to reseal around it. Now I've seen a picture, someone actually has done that, so it can be done. For me it's not ideal because I want to bring my Starlink wire down through the same hole as the solar panels, and I don't want to use that particular hole for a couple of reasons. But it is an option. So I took a very different approach to bring the solar wires down from the roof. I think maybe this is an approach that hasn't been tried before, but I wanted to bring the cables directly into the hidden compartment where the solar wire loop, pre-wire loop is. And the only way to do that, after talking to Willie Newfield up at Leisure Travel Van, is to drill a hole somewhere back from the edge about 8 inches. In fact, I drilled a hole 7.5 inches away from the seam line here where it goes from the flat to the begins with the curved part of the roof here, and then 2 3/4 inches over from this seam, this strip here, 2 3/4 inch here, 7.5 inches here, and then I have to work my way forward into the compartment which is underneath here. So that compartment, that hidden compartment, is under here. The problem is, right in this seam is an aluminum bar, and you have to be able to squeeze under that. So Willie sent me some photos from the production line, which you see here. And the first one shows the fiberglass top as it's being manufactured, and you can see this aluminum angle that comes out and down. He said it comes down about 1 1/4 inch from the top, and then below that is insulation material. And then in the second picture that he sent to me, he's pushing down on this Reflectix type insulation material, so you can see the foam underneath. So the trick is to figure out how to get down underneath that aluminum joint and into that compartment. So I drilled a small pilot hole here, and then I used a 1 1/4 inch hole saw to make an opening here. And so I came up with this dimension by carefully measuring any feature I could to kind of estimate where that pocket in the roof. So there's a pocket up against the roof from that hidden compartment that I can reach my hand back to. That pocket is like here, and I reach my hand and get a dead end when we get to this aluminum plate here. So I don't want to get too close to this edge here, because I'm going to use this combiner box from AM Solar, because I'm going to also put my Starlink cable through here, and I want to have feed throughs and all that sort of stuff. So that's about the closest I was willing to go. You could go a little bit closer with a different junction box, or maybe you can use if you're just bringing 2 solar wires, a gland can get closer. The closer you get to this edge, the easier it'll be, because I had to dig out the styrofoam in here, and then I had to dig my way forward until I ran into an obstacle, which is the aluminum piece that's here. And I used a screwdriver and I vacuumed the styrofoam out, and then eventually I got a piece of long wire, stiff wire, and I inserted it in there, and after a lot of fishing around, I was finally able to get it underneath the aluminum plate and into that compartment. And once I did that, I knew this was going to work. So then I just taped the wires. These are 8-gauge wires. I taped the wires to this single solid core wire, and then pulled them through one by one. It took a little effort, but actually, and then I made a mistake. I pulled the wrong wire, too short of a wire through. As I pulled the wires through more and more, it became a little bit easier. So these are now going into the compartment below. I still have to do my Starlink cable, but I have to cut the end of that off, and I'm going to have to rewire that when I come up to this junction box, because I'm going to have it go into a connector, so I can just plug and unplug my Starlink into that connector and have a connection down below. But if you're not worried about Starlink and you want to just get down into that compartment, that's how you do it. So I can show you the wires coming down in the compartment below. Yeah, and here are the ends of my solar wires from the roof that came in from up above and back, basically back in here in the roof, somewhere up in this region, and then work my way forward till it comes out there. So it worked. So if you decide to follow the same path, you just need to have some patience, go slow, and be careful with the hole saw. You just want to punch through the fiberglass and this, I think it's like an 1/8 inch thick piece of plywood here, and then a bunch of styrofoam before you hit the top of the ceiling. And the key is not to go too far and punch through the ceiling. And like I said, working the way forward here, just slowly and patiently digging out the styrofoam. I used a long screwdriver until I couldn't go any further. That's when I decided, okay, I got to push this through, and that worked. So I need to identify the solar pre-wires down here in the battery compartment. And as you can see, I've removed the battery and I've installed a replacement battery in a different compartment. So this compartment is going to just be used for the charge controller, and that's about it. So it's very easy to find the white solar pre-wire, which is this one here, and it's connected to the ground up there, and it all says solar on it, and it's this 8-gauge wire. So it's in this wire loom, so you have to take that off to find it. Now it's also easy to find the positive wire. So this will go to the ground on the charge controller. This will go to the positive for the inputs from the solar panels. And so there's a fuse, inline fuse holder here when you pop this open, there is no fuse in there because there is no solar panel when this was made at the factory. And you can see one end goes up here to the positive bus bar and the other goes back in here. Now you'll notice it's actually a very different gauge wire that LTV used. And back in here somewhere they spliced it into the 8 gauge red wire. And in many cases you can get to that splice and eliminate this narrow gauge wire and connect directly to the 8 gauge wire. But looks like they did this way back inside here and I can't get to it. So that's kind of stupid if you ask me. Why not bring the 8 gauge all the way down, and if you want to splice it here, leave me a piece I can get a hold to. So I'm going to have to splice my wire to here and then bring it over to the solar charge controller. So here's my solar charge controller. I'm using the Victron Energy SmartSolar. It's an MPPT type, so it'll give me maximum efficiency from the solar panel, 100 volts, 50 amps, and that's in case I do some expansion. I won't need that much with 4 100-watt panels. And what makes it smart is it has a Bluetooth app, so I can connect to that with Bluetooth and read what's going on. So we have a battery plus and minus input and a photovoltaic or solar panel plus and minus input. And so I'm going to splice an extension on the white wire from the solar panels, the pre-wire, and put it in the minus spot, and then I'm going to splice to the red wire from the panels, and I'm going to bring it into this switch first so that I can isolate the solar panel from the charge controller, and then bring from here to the plus input. And on the output, we'll go to the battery. This goes to the plus, this goes to the minus, and I'll have the plus go through this breaker. It's a 30 amp breaker, and that way if there's any issues charging the battery, the breaker will flip, and then I can just reset it once I figure out what's wrong. Now these are not finally bolted in, these are just temporarily bolted. I have to snug them down. So now I've completed the wiring in this compartment, and let's take a look at that. So here's my charge controller and a cutoff switch and a breaker on this side. So first identified the white wire from the pre-wire, the solar pre-wire. That's this one here, and it was connected up here to the ground. So I spliced cable to that, and then that goes into the minus, the PV photovoltaic minus, which is the solar panel negative side input. And then we identified the red solar pre-wire, and as I said before, Leisure Travel Van spliced a smaller gauge wire to that way back in here, so I can't reach the 8 gauge wire, but I spliced my own 8 gauge wire here, and then it runs along here, and then it comes down and goes up into this switch. This way I can isolate the solar panels from the charge controller when I'm doing any work, and you don't want to have the solar panels connected to the charge controller if the charge controller is not connected to the battery for any reason. You could burn out the circuitry in the charge controller. So that switch will enable me to isolate the solar panels from the charge controller. And then from the charge controller, from this switch, it goes to the positive input, photovoltaic positive input on the charge controller. Now the output of the charge controller, the battery minus is this cable back here, a little bit hidden, it goes back up in there, and then this of course is going to go up to the chassis ground here where the white pre-wire used to be connected. So that's the battery minus. And the battery plus goes down to this breaker, input of the breaker, and then the output of the breaker comes over here, and it's in this black loom wire here, comes along here and up, and it goes in to the positive input here. Right, so the positive goes to the positive bus bar here. So I point out that I've already disconnected, before I did any of this work, I disconnected my battery from the system, and I have no AC power plugged in. So there's no voltage anywhere, and it's a good idea to check that with a voltmeter. Just measure from here to here, and you can see that it's okay to work on the system. So it's hard to see the wires, which are which, because they have the black loom on them, but a white pre-wire, the red pre-wire, and those both go over to this area, and then of course then we bring the ground from the battery back to here, and we bring the positive to the battery here, and we're all set then. So that's it. I just need to tidy up a little bit and we're done. And as I said, there were some other wires in here from before. This is the temperature sensor for the AGM batteries. We don't need that for the lithium iron phosphate battery that I put in. And then I still need to figure out what these two wires are. I have no idea what they are. They're not connected to anything on this end, so it'd be a good idea to know what they are. You're going to need a few cables to bring the power from your solar panels to your junction box, and then from there down to your charge controller. So you can either buy pre-made cables, and I'll put links to some of those. They come in different lengths, or you can make your own. So I'm making my own. I'm using some of this 8-gauge duplex wire. So it comes in a big spool. It has both the red and the black, the positive and the negative wires. So you'll need a wire stripper, cutter, and some sort of crimping tool. I'm just going to use this needle nose pliers. That will work fine. And then you need to buy the MC4 connectors. Here's an example of an MC4 connector pair. This is actually 2 connectors in one. It'll come in a kit with these metal inserts that will go inside there and some tools. So you'll need the tool to take this pair apart right here, and that allows you to pull that apart. And so then you have a male and a female connector. Now, while this is a male outer connector, these are called MC4 connectors. The 2 pins that go on the inside, the metal pins that will be crimped to the wires themselves, are male and female. The male is just a nice little bullet, and the female is an open bullet, and that goes in there. Now, what you do is the female insert actually goes into the male outer connector, and the male insert goes into the female outer connector. So just keep that in mind. So then you want to cut your cable to the appropriate length. If you're making your own, make sure you give yourself some extra cable length. And so after I strip these, I'm going to fit this on there, and then there are some prongs here on the end of this, and I'm going to use those to crimp this onto the wire. So when you make these cable connections, you want to make sure you get the right connector on the right color wire. So this is going to be the positive wire, and coming off the solar panel, you'll see the male connector labeled to the positive wire coming off the solar panel. So we don't want to put this one on here because we'll have 2 males, male to male. So we'll want to put the female on here so I can connect to the positive terminal coming off the solar panel. And then on the other end, this is going to actually be bare wire. I'm going to strip this back, and it'll look like this. and I'm going to connect this to the bus bars inside the junction box. So this will be carrying the positive from the panel, and this will be the negative from the panel, and I'll hook them up to the positive bus bar and the negative bus bar. So just make sure you get your polarities correct, because obviously somewhere along the line you're going to have to use both of these on each wire, because that's how it's designed to work. All right, so let me do the connection on this one now. So since this is going to be the positive wire from the carrying the current from the solar panel, I've put the male insert on it, and then I'm going to, after I crimp this, I'm going to insert it into the female MC4 connector. So let me crimp this on. I'm going to bend down these tabs a little at a time, trying to get them to overlap as much as possible, and then make sure everything is tight, no wiggle at all in that. The way this is constructed, it has three pieces. It has the outer nut, it has a water seal, and then the front end. These can all stay on here. You don't need to take them off. And then we can just simply insert this in here until we hear the click. Okay, it clicked. You may not have heard that, but I can't pull it back out. And now we'll use the tools. One end connects. Before we do the tools, let's tighten this by hand, and then we'll use the tool to finish tightening it. So one end goes on there. This cutout on this end goes over here, and then we can turn it until this clicks. There we go. And now that's secure. So it's positive will connect to the positive output of the solar panel, and then the other end to the bus bar on the positive side. Now I just need to connect this one in the same fashion. Now, depending on how many panels and wires you have, you may need to connect multiple cables, positive and negatives from a pair of cables together, and you can get some of these branch connectors. And so, for instance, this one here will take 2+ connectors and allow you to put them together, join them, and have a single plus output. And this one will allow you to take the inputs from 2- connectors and bring them into one. So these can be very helpful to combine things. In my case, I won't need these. I only have 2 pairs of cables coming in to my junction box, and I'm going to just wire the 2 red to the red bus bar in the junction box directly, and the 2- to the minus bus bar in the junction box. But if you didn't want to do that, you could combine the reds on the outside and have another cable on this end with a connector here, female MC4 connector, to a bare wire to go in your junction box, and the same thing over here. Now, in order to complete the circuit from the panels on the roof down to the solar charge controller, I'm going to need to connect the wires coming down from the roof, these 2 wires that I fished through here, to the wires going down to the charge controller. Now, this is the loop that is back in that hidden compartment there. And so the way to do this is to simply cut the wires and then use one of these butt-end connectors. So this is a 8-gauge butt-end connector. Strip the wires, put it in here halfway, and then crimp it with a crimping tool, and do the same on the other side for the corresponding other wire. So red to red and black to white. Now, which part of the loop do I need to connect to? Because once I cut this loop, I'll have 2 sets of wires, and one, as we said before, goes around behind here, and it's the end in the behind the control panel, and we don't want that one. We want the one that goes back down behind this wall to the old battery compartment. And you can just fish around behind in there with your hand, and you can probably feel which one goes down the wall and which one goes back. And just to be sure, you can put a voltmeter on these and use a long extension on your voltmeter to connect down into the corresponding wire in the battery box. That way you'll know which one of these sets of wires is the right one to wire to. So after carefully butt splicing these wires together, I finished it off with some heat shrink tubing here to make a nice clean installation. So you could make this shorter. A lot of people worry about power loss. I think they overestimate the power loss. Anyway, there's a lot of cable here in case I need to pull more up on the roof for some reason. I'm going to roll this up and use some electrical tape to make a nice little bundle and stuff it back inside that hidden compartment. And so this phase of the installation is complete. If I just needed to connect these two wires to the solar wires coming from the panels on the roof, I could just use a simple gland to make that connection and a nice tight seal on the roof. I would use something like one of these glands or any of the other brands out there. But I'm going to also connect my Starlink cable up through the roof. So I'm going to use one of these junction boxes from AM Solar. And so this junction box will go over the hole here like that. And then it has these bus bars, the plus and minus bus bars. And then I have cutouts that I made. There's cutouts for this. Will bring in two wires, a plus and minus from one pair of panels, and this will bring in the plus and minus from the other pair of panels. And this other knockout is for the Starlink weather-tight seal connector, which I don't have yet. It's coming in tomorrow. So this simply attaches VHB tape. So it comes with two big pieces of VHB tape. I added some more here, and then we'll just mount it there over top of that. And then after the VHB tape cures, I'll put some Dicor sealant all the way around the edges to make a nice tight seal. And when I have everything wired up and connected, then I can put the cover on here. The cover attaches with some bolts and it clamps down on this rounded edge, and it fits in this groove inside the lid to give a nice watertight seal. So the last thing I needed to do is bring in the new cables from the solar panels to the junction box and wire them into the bus here. So here's the positive bus. I have two positive wires coming in because I have 4 panels and they're grouped in 2 pairs of panels in series. The 2 in back are wired in series, and that means the minus output on one of the panels goes to the plus on the second panel, and then I wire with my new wires those remaining plus and minus wires up to this junction box. And so that's this pair of wires here, one positive, one negative. So wiring those in series doubles the voltage and keeps the current fixed. So nominally it's 40 volts and 5 amps. So that would be 200 watts. And then do the same thing here. And then here's that pair coming through here. So what we have on the bus bar is nominally 40 volts. And then we have 2 times 5 amps coming in, 10 amps, 10 times 40 is 400 watts. And then we have the wires going down to leisure travel vans pre-wire, and we're all set there. Now you'll see one opening I still have here. I'm waiting for the connector. It's a watertight feed through for an RJ45 jack. So as I mentioned before, I'm going to attempt to bring my Starlink cable up here, and of course I'm going to have to cut the cable and put a new RJ45 connector on it. On one end, plugs in there, and then on the other end it'll go to the Starlink itself. So that's in addition to this whole solar upgrade. And then this lid will go on top here, and then it bolts down with bolts to give it a good seal. And as you can see, this thing is held in place pretty well. It's got the VHB tape, and then I have the 3M 4200 to both seal out water and to add some adhesive power to it. So this thing's not going anywhere. And I think I just button this up, and then we'll see what we get as the sun starts to shine. So I'm now connected with the Victron SmartSolar Bluetooth app, and you can see on my phone that I'm charging at 238 watts right now. And yes, it's a 400 watt panel installation, but we have only partial sun and the sun is low in the sky. So that is to be expected. And you can see this shows the current voltage, which is just a little bit less than 40 volts. And the current is 6.2 amps. So basically the voltage should be close to 40 volts. There is some delta in voltage with the panel performance and some modest loss in the resistance of the wires down. But I don't think that accounts for most of that delta from 40 volts. And if you look, they have this nice history feature. And if we look back to when I was on a trip and out in the sun, and even then it was partly cloudy those days, you can see I hit a maximum of 374 watts on one day, 354 on another, 326 on another, and so forth. And I was able to charge, even with partial clouds and some rain and so forth, about 1,300 watt hours during one of these November days. So that's not too bad. So far, I've been very happy with that. If you get the Victron charge controller, I highly suggest you get the SmartSolar one with the Bluetooth app. And if you don't get the one from Victron, you get from someone else. Others use similar Bluetooth apps as well. This is very handy to have. So there you go. So that brings me to the end of my step-by-step complete guide for installing solar panels and solar charge controller on my RV. I hope you learned something useful from this video, and I would appreciate it if you would like the video. And if you want to see future videos like this, you can always subscribe to my channel. And as I mentioned in the beginning, I will put links to all of the components that I used, plus some other optional ones which I didn't use but you might be interested in, down below the video. And as I mentioned before as well, please use my links. And as I also mentioned before, I would appreciate it if you use those affiliate links of mine, because it does help support this channel and it doesn't cost you anything extra. So thank you for watching.